Guys, this video is going to be on categorical variables, categorical data, and it's going to start with our Blackboard site, and let's go to content, and I want to go to handouts, and under handouts you're going to see summarizing categorical data. So go ahead and download this and have it handy. All right. Now, one more thing we're going to need is we're going to need a data set, and the data set that I want to use in this is called ACT Parent and School. So I'm going to go ahead and download this, and I'm going to open it up. And I don't want to do all that stuff just yet. And well, oh, there we go. Okay, so I want to save this on my desktop because I'm going to use this in just a second. Okay, so it's saved on my desktop. We'll get into Stack Crunch here in just a second, and we'll go get that. So if you've downloaded the handout from Blackboard, I want to run over a few things. Again, the title of this and what I'm going to teach you in this video is how to visualize and summarize variation in categorical variables. You know, we run into things that are quantitative, and we run into things that are categorical, and the way that we visualize and summarize the data is in stark contrast depending on the type of measurements that we have. So guys, so far we've looked at techniques that are appropriate for quantitative variables. We've talked about means and medians and standard deviations and quartiles. So these four are numerical summaries, and these two, histograms and box plots, are pictures. That's the way we visualize variation. So these techniques are not appropriate for categorical variables. So categorical variables, let's say, what should we think? Well, gender, political party, eye color. All these variables that we can go out and collect that aren't represented by numbers. So if something's represented by a number, it's quantitative data. If it's represented by words, it's categorical variable. So what is appropriate? Well, guys, instead of mean, median, standard deviation, and quartiles, what we look at is we look at frequencies and percentages. It turns out these are really easy to find using Stack Crunch. Instead of using histograms and box plots, we use pie charts and bar charts. Now this is a little confusing because bar charts are very similar to histograms. Big difference is the bars don't touch on a bar chart. The bars do touch on a histogram. Second big difference, histogram ordering is important. We go from smallest to largest. Bar chart ordering is irrelevant because we have things where, they're words. There is no natural ordering. So again, I kind of summarized that here. Bar charts and pie charts are used instead of histograms and box plots, and frequencies and percentages, what we talked about up here, are used instead of means, medians, standard deviations, and things like that. So again, bar charts, order typically doesn't matter because there's no natural ordering. For example, political party, Democrat, Republican, moderate, Tea Party, all the different classifications that people can fall into. Some people may tell you there's an order, but there's not at least in terms of statistically speaking. So if ordering isn't applicable, neither is distribution shape. Because guys, remember, distribution shape is like what? Negatively skewed or left skewed or right skewed, positively skewed. Well, guys, if we create a bar chart and ordering isn't natural, then we could reposition the classifications any way we want. So ultimately, we could get any distribution shape that we want. For example, if I have a bar chart, just to give you an example of one, and I'm looking at males and females, and let's say I have 100 males and 50 females. Again, these bars don't touch in a bar chart. Well, you might say, well, that's a positively skewed distribution. You'd be completely wrong, because I could switch that around and put females first and males second, and completely change the dynamics of the bar charts. So, guys, distribution shape is not applicable. So make sure that is in your notes. Now, sometimes we run into what's called a Pareto chart. That's just a bar chart where they're arranged in descending order. So, let's say we go out and we look at political party at Shawnee State University, and I have no idea what that would look like, but let's say it looks something like this. Well, a Pareto chart would just put this one first, this one second, this one third, so you'd have a decreasing order for the frequencies. Guys, pie chart, another frequently reported graphical summary for categorical data. Shows the proportion of observations belonging to each group or category, where these categories are represented by a wedge in the pie. So if we were to take a bar chart that looks something like this, well, we would create a pie, and we would see that about double the area for males is needed for females. So, guys, we would end up with something about like this, where males would be there and females would be there. So, again, technology is going to do this for us. It's just a matter in this class that we know the appropriate graphical method for summarizing categorical variables versus quantitative variables. And once we get these things, we can draw information from them. So, all right, gang, let's and then here I tell you mean and median for quantitative data is replaced with the mode. The mode is just another measure of central tendency that tells us which group or which category occurs most often. So, guys, up here the mode would be male because it has the highest bar and it occurs the most. Okay. The great thing about categorical variables, at least at this stage, is I really can't make this stuff hard if I tried. So, so anyway, and I wouldn't try to make something hard anyway. All right, guys, let's make some things happen here. Let's go get the data set ACT parent and school and take a look at it. So, guys, I'm going to go to my math lab. And I'm going to go to StatCrunch. I'm going to go to the website. And I'm going to select a file on my computer. So, guys, I want to go get on my desktop ACT parent and school. And I want to load the file. Now, you probably see why I like this data set for this type of video where we're looking at categorical variables, because all the information we have here is categorical. So what happens here? Let me just run through the variables with you. First of all, it's in the right form because, as I talked about in previous videos, when I read left to right, this 10th person, their ACT score was below 28. Their parent had no college, and they attend a public school. So when I read left to right on the line, down here, ID 79, this student had an ACT 28 or higher, parent had no college, and they go to public school. So again, when we read left to right, we need the information on that particular line to be represented by one subject. In this case, it would be one student. Okay? So what I want to do is I want to get split screen where you can see both. And I want to answer the questions using Stack Crunch. So the first thing says, the first question, part A, says find the mean, median, standard deviation, and IQR for all three variables. Well, guys, this is a dumb question. It was trying to kind of bait you in. Guys, mean, median, standard deviation, and IQR are appropriate for quantitative variables. All of these are categorical, so it's not even appropriate. So even, if you get caught not thinking and you go to stat and you go to summary stat and go to column and you look for select column, you'll see the only thing that's given is ID, because the only variable that deals with numbers is ID, and really doing a statistical analysis on ID would be completely and utterly foolish. So we can't do what we're used to doing, and if we do try it, it's not going to work because we don't have quantitative variables. So part A is just a dumb question, doesn't apply. Now the next thing, what percentage of the students scored 28 or higher on their ACT? Well, guys, I can go over and do that. I can go to stat, and I can go to tables, and I can go to frequency. So I want ACT because that's the variable that I'm interested in. I don't want a group, but I want the frequency and the relative frequency. So I want to choose both of those. Okay? I want to compute. And when I compute, I can see that I get exactly what I talked about earlier, the frequency and the percentage. Just as I talked about, if we go back to what I talked about earlier, we summarize this type of information using the count, the frequency, and the percentage. So what percentage of students scored 28 or higher? Well, when I go to 28 and above, I see that there were 105 students. The relative frequency is 0.5965, so I would say that 59.7% scored higher. Now, what if I ask how many of the students scored 28 or higher? Well, then I would report the 105. Okay? Second question, what fraction of parents have college experience? Guys, same thing. Go to summary stats, go to columns. As I said, don't do that. Go to tables, go to frequency. We want the parent information, and I need the same thing. But now it says what fraction. So the fraction of parents with college experience, I see from my output that I have 79 who have college experience to the total. So what's 79 plus 97? 176. So 79 out of the 176, well, there it is, duh, right in front of me. 79 out of the 176, so that would be the fraction that has of the parents who have college experience. Next question. What percentage of the students attend private school? Stat, tables, frequency, high school status, compute. So what percentage attend private? It would be 34.7%. Again, guys, frequency and percentage. It's a count, it's a fraction, or it's a percentage. Now, part E throws a little bit of a curveball, but luckily Stack Crunch handles it really easily for us. For the parents who attended college, what percentage of their children had an ACT of 28 or higher? Well, guys, what I can do here is I can go to stat and go to table, and look at a contingency table with data. And what I want on the row is I want to investigate the parents who attended school. So I'll put parent there. And I want to see what percentage had an ACT, so I want ACT. Now what I want here is I want, what does it say? For parents who attended college, what percentage of their children? So what I want here is I want row and column percent. So what we get here is kind of a nice output. We can see that for parents who attended college, so that's this line right here, what percentage of their children had an ACT of 28 or higher? Well, we can go to this first square and see that it would be, what would it be? It would be 28, so it would be 65. Okay, so of the parents who attended college, so we had 79 who attended college, ACT of 28 or higher. Okay, so what we're looking at is we're looking at the row. And if you look up here, you can see that the row is the first value that's in the percentage, in the parentheses. So the answer here would be 82.28%. Now, what percentage who attended college have a child who scored below 28? Well, again, we're focusing on this first row, attended college, so it would be 17.72%. Now, we get into some chi-square stuff. This is fancier stuff we may get into a little later, but we don't have to worry about that stuff down there. All right, question F. What percentage of students who attended private schools have an ACT of 28 or higher? So guys, I need contingency because I have two categorical variables. So the two that I'm looking at is public-private, high school status, and I'm interested in examining that over ACT. So I want row percent and column percent again. So what percentage of students who attended private school? So guys, I got tunnel vision on the first row. Have an ACT of 28 or higher. Well, guys, that would be 73.77%. What type of graphical display would be appropriate for school? Well, guys, school is categorical, so we would be either a pie chart or a bar chart. Create a box plot for parents' education level. Well, again, dumb question. Box plots are appropriate for quantitative variables. Parents' education level was either college or no college. Box plot is not appropriate. And I think, at least I hope, that if we go to graph and we do a box plot, notice that parents' education level isn't even there because it's just not appropriate. So there's no reason for that variable to be able to be selected. Create a histogram for ACT scores. Again, dumb question. Now, if ACT scores were provided as 18, 17, 26 as the ACT score, then a histogram would be appropriate. But we have ACT scores cut in terms of their relationship to 28. It's either 28 and above or below 28, so we've categorized it. So guys, it is not appropriate. Create a bar chart for ACT scores. Create another bar chart for ACT scores grouped by parent education. So let's do the bar chart first for ACTs. So guys, you can see it's very easy. We have the data. We want ACT. There's no building, there's no grouping by, split bars, we want frequency, value ascending, that's fine. And let's go ahead and compute. So guys, again, bar chart, right? Kind of looks like a histogram, but it doesn't because the bars don't touch. And distribution shape does not apply. That's really cool. If you just hover over that bar, you can see that there's 105 students with ACTs of 28 and above, and there's 71 students with ACTs below 28. Now we get a little bit more sophisticated, a little bit more complicated here when we do another bar chart for ACT scores grouped by parents' education level. Well, same thing, bar chart with data. So we want ACT score, but we want it grouped by parents' education. Now this gets kind of cool because it gives you more information because you have more going on. And what we can see from this output is we can see the comparisons. First of all, I hover over that, I see that I have 65 of the 176 who had an ACT of 28 and above, and their parent went to college. 28 and above, no college, there's 40. 14 had an ACT below 28 whose parent went to college. And 57 had a below 28 parent with no college. So what you can see is you can see the relationship here between the parent's education level. Blue is college. Well, more than likely, going to college, their son or daughter had an ACT of 28 or higher, yet when they didn't go to college, they were more likely, you might say, to get an ACT below 28. So, you know, I've always been somebody who's really more impressed with numbers, but a lot of people, if you were presenting data or presenting summary statistics and you're wanting to summarize this, a lot of people are much more visually impressed. I'm much more quantitatively impressed. But charts are nice. I mean, they summarize very quickly important patterns of our data. So guys, the last question. So this is done. So the last question is create a pie chart for type of school compared to the frequencies and relative frequencies. So I'm going to have a couple things going here. First of all, for type of school, I want to come into tables and just do frequency. And I want to go to high school status, and I want the frequency and relative frequency. So I can see that I have private has 61, and I have 34.7%. Public is 115, and I have 65.3%. So guys, when I do a pie chart, you think about it, a third is 33.3333%. So about a third of my circle is going to be colored, whatever the color is that corresponds with private, and about 2/3 of my pie chart is going to correspond with whatever color is public. So let's do that so we can see we have a pie chart with data. And I think we want to do what? School? High school status? Now we've got all sorts of things. We can build, we can group by, we can do count, we can do percent of total. I'm just going to do count. I really don't care about start angle 0, so we can rotate it as we need it. Guys, I don't want to get too fancy here. I just want to have a nice pie chart. And you can see that approximately 2/3 of the circle is public and about 1/3 is private. So again, someone like me, I would be more tempted to look at the frequency and percentage, but other people like to visualize variability with a pie chart or a bar chart. Well guys, that's all I got. The end. Short video. Those are the kind we like, right? So have a good one.